do not consider that an interruption. Quite the contrary. This is not a monologue. So always stop me if you have questions, please. So after we found the slope and we put it in the point slope form, we have to solve for y. It's always mandatory to solve for y. So I will distribute this to x, 2 natural log 3 over 3 times x. I will distribute this to negative 3, but the denominator will go away, so minus 2 natural log 3. And I have to move this to the other side. So it's negative natural log squared. So now it's positive natural log squared. And this is it. You don't have to do anything else. You don't have to approximate. We want exact numbers. We don't want to do anything else here. That's it. Okay. So I will probably not attach that later. Okay. So the daily concept check. Can anyone help with any of these formulas? So from 2.3, I have to explain one more property and then, or differentiation rule, and we have to look at at least one word problem, and then we can start chapter 3. Can anyone help with any of these? I'm opening Pearson in the background. That's all I'm doing right now. Can anyone help with any of these? I'm ready when you are. Yes, I'm ready.
E to the power of x prime is e to the power of x.
That's it. That's the easiest possible function to work with. There is nothing easier than that. Yes. Then e to a function. This is f, not x. F does not equal x. It's a more complicated situation. Can anyone help with this? Remember how silly I was last time? Just for you to entertain you a little bit and just refresh your memory, and so you never forget those magic words. I'll do anything to entertain my, yes, e to f times f prime. Awesome, great job. Yes, times the inner function prime. Those are the key words. Excellent. Can anyone give us the formula for natural log x? And I am opening on page 217. So page 2, multimedia library, 2.3. Yes, I'm ready. Natural log x. Yes, indeed, 1 over x. Finally, the last one that we looked at and we practiced last time. Anyone?
1 over f times inner function prime.
Awesome. Wow. Wow, I got 2 inner function primes tonight already. Awesome. Great job. You will never forget. I know I'm silly. I'm trying to be entertaining sometimes. Okay, good. So we want to talk about something important right now. So this is the absolute value of x. Anyone remembers what does it equal to? It's okay if you say I don't remember.
It's how far our number is from 0.
Excellent. So x, the absolute value of x is the distance, excellent, from 0 to x, or from x to 0, whatever you want to say, it doesn't matter. So the distance from 0 to x, or the distance from 0 to x, from x to 0. Yes, awesome. Which means it has to be positive, because the distance cannot be negative. Great job. But the formal definition of the absolute value is this. It's x. If x is positive or 0. In other words, I'm saying if this is a positive number, you can erase the absolute value. But if x is negative, then you, instead of the absolute value, you put a negative in front of x. If x is negative with negative in front of it, this will always be positive. This is always positive because it's greater than or equal to 0. But if x is a negative quantity times negative in front is also positive. And you can say, why do you need this? Why are you talking about this right now? And here's why I'm talking about it. Because we also want to look at the absolute value of x differentiated. See, I haven't talked about the absolute value here. So this is a special situation. And you will see this is very important for chapter 4, crucial for chapter 4 to understand and remember this. So I am really trying to talk about this, but I have to take it slowly to explain the formula. And then we'll practice it in a minute. Okay, so first we identify what the absolute value equals to. So there are two options for the absolute value. X or negative x, depending on x. So the absolute value of x is x if x is a positive number or 0. But the absolute value of x, in other words, can be replaced by negative x if x is negative. Negative times a negative is still positive. Now, before we get here, we have to analyze natural log of the absolute value of x. Now, if this piece has two options, this piece will also have two options. What are they? Natural log of the absolute value of x when x is positive, and natural log of the absolute value of x when x is negative. I have to be careful because if you remember, natural log is not defined at 0. Not defined at 0. So x positive, I cannot copy the equal symbol, and x negative. So the absolute value has two options. Natural log of the absolute value will also have two options. However, I cannot include the equal symbol because I cannot plug in 0 in natural log. Now, we want to differentiate this. Because this has two options, the derivative will have two options, at least initially. So, am I still focused in there? Yes, I am. That's page 2. So now I want to differentiate this, which will be differentiating this and differentiating this. Two options, two derivatives. And now I continue. Can anyone give us one more time what this equals to? And I will put it here. That's what it is about math. Repetition, repetition, repetition. Anyone?
1/x.
Thank you very much. For x greater than 0, as you see, I could have not even put equal symbol because 0 in the denominator is not allowed. Awesome. Now, what about the second branch? Can anyone differentiate this? Yes. It's okay if you're wrong.
Would it be negative x?
So we have to use this formula.
Would it be 1 over x times
Careful, careful, careful.
1 over negative x?
Excellent.
Times negative x? Negative 1?
Exactly. But look at this. Wow. Same. Because 1 over negative x times negative 1 is still 1 over x. So then we will say that even natural log of the absolute value is 1 over x. Finally, so please add this to the list of rules. Finally, natural log of a function prime. Who would like to try this one? It's okay if you're wrong. I'm here to help you.
Would it be 1 over f
Yes?
times f?
Yes. Not f times the inner function
F
prime. Yes, but with the absolute value. Awesome. Great job. Good. So let's practice now. I'm ready. I'm going to share my screen. We want to go to page 216. Where's my keyboard? Here it is. Enter. Okay. So let's see if we want to practice anything else. We looked at these types of problems. We looked at the tangent, the last one we did last time. Let's look at a word problem now. Any questions? I don't know.
26.
Which one?
26.
26, advertising. So a model of consumers' response to advertising is given by N of A. So this is 26. N of A equals 1,000 plus 200 natural log A. And of course, A has to be a number greater than or equal to 1. N is the number of units sold. Always take notes, units. And A is thousands of dollars. So this is in thousands of dollars. Okay. How many units are sold when 1,000 is spent on advertising? So careful, A is in thousands. So I have to replace A by what if I am told 1,000? What am I replacing A by in this situation? How many thousands is 1,000?
1.
Exactly. Thank you so much. So N of 1 equals 100 plus 200 natural log 1. How much is natural log 1?
This is 1.
Natural log 1 is 0. If you ever have any doubts, go to natural log, plug in 1, close the parenthesis, and enter. Good. Part B. I'm sharing. Part B. Find n prime of A and n prime of 10. n prime of 10 will be when a is what? When a is
10.
when a is, you're right, but what does it represent, the 10?
When 10,000
Yes,
units are built.
exactly. That's all.